体となって見事なハーモニーを奏でました。しめ縄はどう思う？とっても太いと思います。
帽子の中に誰もいませんよ。
カエルがケロケロ雨にも負けず寒いと遠いに密着しさまですにカエルがぴょこぴょこ風にも負けず尻尾はニョロニョロおたまじゃくしですにおたまじゃくしですにあうあうあいIt is a nice boat indeed. It is a nice boat indeed. Ah. And as we know, it's not actually the creature, it's the hat that's the god. Hello! Hello everyone! Hello and welcome to this new Parasite Classes. I hope that you liked the intro. I hope that you did, because I freaking love Toho. I did too. I vibed to that too. Like, you need to understand, I am a big Toho nerd. I might even like expose like I watch a Vtuber that is like a slime who is specialized, who only ever plays Toho games and fan games. You just call Suwako a creature? I mean, she's small in French. I mean, she is a creature. She has been made by our Lord the Creature, by our Lord the Creator, creator. But yes, welcome to Parasite Classes, and we will have today an intro on Amphibia. And on we will dedicate this episode to Sicilians, because we will do multiple parts indeed for the amphibians. I think that the next one will be on frogs and toads, so that I can include another meme song, and after that maybe we're going to be a bit more serious. I do not know. I do not think so. Serious in me, like serious hasn't found me yet. I haven't been found by Serious Black yet. But to continue with traditions, we'll begin with frog VTubers. Indeed, we can see that we have a lot of frog VTubers. Indeed, like Takanashi Kiara, Kami the Frog, very esteemed frog VTuber. Froggy Lock, who also rigs and makes her own model, which she doubles as an artist. Very, very good models, by the way. And the amazing Ribbit. We have Omura Ignis as a salamander. And there is a lot of representation by axolotls, and I've dedicated this one to Mai. Indeed, I'm Frog. She said that she's a frog, so indeed she is a frog. I mean, it's self-evident. She lays eggs. Of course she would be a frog. Of course she would be a frog. She lays eggs. And I would most likely say amphibian VTubers. And I know that salamanders are not exactly the same, but I don't care. For me, like, if you say that you're a salamander, you are a salamander. You take your phylogeny with it, and so you are related to Kermit the Frog. Thank you very much. Thank you very much. Amphibia come in the etymology. It comes from amphi, which means both, and bios, life in Greek. So literally a creature that has two lives, that has both lives. You saw Sicilians and it was like, wait, but we already covered octopi. I think we did octopodes already. No, we did not. We did not do octopodes. Absolutely not. We did not do that because we did this Deuterostomians before Protostomians. So octopodes is going to be very far in the future. Very far in the future indeed. But you'll see what a Sicilian is. Very fascinating creatures, by the way. And amphibian does refer to the two stages of life of the amphibians, with a larval stage and an adult stage. I mean, a metamorphosis that leads to an adult stage, because they're still juvenile and subadults and juveniles, which are very different. Like subadult is very small compared to an actual adult. Which you can see in frogs and other things. It wasn't an Orthodox joke. It was a Splatoon 3 joke because it was the Samba ray. It was the ray, big ray, the big manta ray. It was in the cartilaginous fish episode. It was in the cartilaginous fish episode, indeed. And yes, in amphibian history, they find their origins in the Devonian, and scientists prefer the group Stegocephalia to define modern land animals, because it's not modern land animals, like just land animals. Because they do a clear distinction, because Stegocephalia allows them to do a distinction between Tetrapodomorpha and Tetrapoda, with Stegocephalia being a clear parent group, having a common ancestor with both of them. Ichthyostega and how his eyes closed out of a primordial soup. More like Ichthyostega and Acanthostega are going to have one slide, not each, one slide for both. Because while they are interesting, I doubt that they crawled their ass out of a primordial soup, and you will see why. You will see why. It excludes, of course, like Tetrapoda exclude Ichthyostega and Acanthostega, which are Stegocephalia, which are within Stegocephalia. Tetrapoda being the crown group from Stegocephalia. But yes, we are still going to talk about Ichthyostega. But now I want to do a bit of phylogeny. I want to talk about crown groups, because it's actually pretty interesting, and it comes to considering that you have common ancestors. You have the last common ancestor for both of those groups here, and the crown groups here would be here and here, and you consider this to be the crown group. You consider this to be the crown group here, and every single member that share this last common ancestor is going to be included within the crown group. And I did an example here, which is like pretty self-evident given that we're in amphibians. And urans, for example, frogs, and the common ancestor of all frogs and toads. So all the frogs and toads and the extinct members of the Anura family, so for example the Costa Rica golden frog, golden toad, and all the other Anurans, so all of the extinct frogs and toads that share this the last common ancestor, are within this crown family, which would be Anuran. This crown group, if you understand what I mean. Basically, you define a last common ancestor, last common ancestor, and whether they are extinct or not, you will consider them part of this crown group. Ichthyostega and Acanthostega are not part of the crown group Tetrapoda. They separated a bit before. They are in Tetrapodomorpha. Ichthyostega is actually super big. For an animal of the Devonian, it's actually super big. You need to consider that it was about 1.5 meters tall, long, which for an animal was actually like ridiculous during the Devonian, where the biggest thing that you would find was a giant, dragonfly, a giant dragonfly. Like that would be the biggest thing you would find, with also the giant millipede and the giant scorpions. Like if they were apex predators of the Devonians. But here's the thing: we never had any parts of the upper members of Ichthyostega. We didn't have any fossil evidence of the upper member. So for me, I consider that they are relatively close to Acanthostega. Just small but large, yeah, very large for the Devonian. Actually, very large. Especially when you consider that Acanthostega, which is also fairly large for the Devonian, is this small. It is pretty much, it's extremely small. But both of them are still very adapted to the life within the water. So I don't think that they are, you know, the true ones that crawled into land. But they are they have a lot of land adaptation. But the limbs are not there yet. To actually support the mass and have actual terrestrial life. That is not something that they would be able to do, in my opinion. Ichthyostega is also very interesting since its lower limb has been compared with other lower limbs, and would be like pretty much the the stage next to last, the next to last stage in the evolution of the limb to go to land. I don't know exactly to say, like avant-dernier, the one before last. It will be the one before last. Like it actually evolved. Like it has like 7 toes that you cannot count here. Like here I count 6. Some say that it has 7. I count 6. I'm sorry. The reduction of toes will actually be something that is advantageous for terrestrial life, because it allows you to have more pressure within them, which you would think is not that advantageous, but in case of hunting and actually being able to have grip on the terrain, that's actually pretty cool. Also, Ichthyostega shows more adaptation towards land than Acanthostega, like a lot more adaptations. Especially within the spinal column. And within the tail. As you can see, it's like night and day. You see a clear adaptation to water here, with a spinal column that is more akin to a fish, for what you would see in a modern fish with Acanthostega. And Ichthyostega, a bit less. Like you would say a bit less. Now, I'm going to quickly do a quick thing about what they have in common. Like what all the extant mean that they still live. So the still living members of Amphibia have in common. And it's a larval phage that shows, well, an aquatic life. Except for one, Sicilian. Axolotl are a bit of an exception. I mean, both of those, Axolotl and Sicilians, are an exception. Nice. Just a moment. I have the itchy nose. Better. But yeah, you see a mudkip. I like mudkips. But here you see an axolotl which is in a permanent larval stage, so much so that if its environment is being disturbed, it could actually go into a state of pseudo metamorphosis, which is pretty deleterious for them. They are able to live. They spend their whole life underwater, and more than that, they are able to reproduce within their larval stage. And as you will see, like a neuron, you would say that it's a it's a 9. It is like, for example, it would be like a 40-year-old lolly. I say this word, but it's the human equivalent. It's very much the human equivalent, except that the lolly is actually like as big as a grown man when it comes to size. Think of the proportions. It is disturbing. If you are a newt, if you are a salamander, you see an axolotl, it is disturbing. Why do you have a 9 ball? But yes, then you have the Frogge and toads. There you this is the larva of a newt, and this is a fetus from a Sicilian. Because a lot of Sicilians are not actually born during the larval stage. They actually develop further than that, either do the metamorphosis within their mother's womb, or straight after they're born out of the eggs. And of course, coming with that, they do eggs. It is most common for them to do eggs. Delicious egg. This is a newt egg. This is, of course, this is a frog with all of its egg, with all of its spawning eggs. And this is a Sicilian guarding its own eggs. And here's the thing with eggs that you need to understand, is that the black stuff you see is the egg cell. The black stuff you see is the egg cell. The white stuff is the vitellum. This here is an embryo. This right here is an embryo that is currently in one of its stages of development. The embryo, being so big and so visible, allowed a lot of development in terms of, well, developmental biology and biology and all that. A lot of those has been decided using amphibian eggs, especially from frogs. Especially the model animal here would be Xenopus. Frogs from the genus Xenopus are especially prized for developmental biology. At the very beginning. Now we're more with zebrafish and fruit flies, zebrafish. But let's be completely honest, they're still very useful. No spoiling. They are still extremely useful. Especially here, since we have a study where they've been able to basically create with a high rate of fidelity twins, like actual twins, by cutting the embryo. And you see that this is the ventral, dorsal, left and right. So this right there is the back, this is the belly, this is right, this is left in the embryo, because the embryo quickly polarize. And you see something that is very, very cool with it, is that when you cut the embryo right with a certain axis, within a certain axis, which is the axis between right and left, between front and back, you see this polarization still in the twins. So the embryo is able to recover from the wound. As I read from the paper, about an hour later the wound was recovered from, and it leads to a lot of twins. Like, these scientists have been, as you can see in the paper here, have been developing a method to try to understand how twins are made with more fidelity. What is the ideal stage in which twins are made? And well, they developed it by literally cutting embryos in half. Of course, since an embryo is basically a hollow cavity, it creates a wound, so it can easily make it die. Which is why having this kind of temporal axis, having this kind of synchronicity is very important. Egg Indeed. There's a lot of egg. But we're going to look at the three main families. The eggs go in the hat. That they do. That they do. So yeah, we're going to we're going to look at basically the three main families in the preceding titles, in the preceding installments. Of course, the Anurans, the Chordata, and the Sicilians. Something that I find really, really weird when it comes to amphibians and the way we classified them is, say, this one doesn't have a tail. Like, the etymology of the names, Anurans doesn't have a tail. Chordata has a tail. Sicilians, it's Latin to... it's Gymnophius, so naked snake, naked serpent. That's what it means. But in Latin, because we use the Latin a lot for them, Sicilians means blind ones. Pepes, worms, and lizards. They're not lizards, they're salamanders. And newts. I mean, they look like lizards, but I most likely say like worm. And yeah, I have a bias towards worms, but please, you have a bias towards mammals. I have a bias towards worms. We are exactly the same. We are exactly the same. I have more empathy towards the Sicilian because it looks like a worm, but I have for a baby monkey because it doesn't look like a worm. But I have to say, it's very cute. And it's the absolute terror of Tenma Miami. And today we're going to look at the Sicilians. Isn't it cute? Isn't it cute? Don't you think that it's so cute? I love Sicilians. Like it has, like you see the two little eyes here. In case you didn't see it, it's very intimidating at first. But then you see the two goofy little eyes here because they're completely blind. They're kind of cute. And they develop the worm. The worm. But yeah, okay. So at first, to be completely honest, I'm going to be 100% honest with you. At first, I thought that it would be a general episode and a quick overview of frogs and newts and Sicilians, you know, as a cool surprise. And Sicilians would be a cool surprise within them. And I would do frogs and newts and salamanders and all that. Easy. I need to show you something. This is Sicilians! You don't hear the thing. You actually don't hear it. That's actually... shit. Okay, so... Just a moment. Just a moment. Okay. Now you should. Let me go back. So, this is the problem. There's way too many Sicilians. I clearly underestimated the numbers and diversity of Sicilians. And because I have a worm bias, I'm going to not do them all, but I'm going to do a proper episode for them. I'm going to do a proper presentation for them. We're going to see their main characteristics. We're going to see what makes them special. Because they're worms, goddammit! They're amphibians that reverted to worms. I mean, evolved into worms. You know, they didn't revert, they actually came into a new space of existence by being a worm. And because they are worms, and they do a lot of... I'm going to give them the honor. I'm going to give them the honor of having a proper episode about them. Even if it's relatively short. I mean, of course, like, Annelids are going to have their own dedicated episode. Annelids is most likely will be the longest episode. Annelids are most likely going to be the longest episode. Because of my warm bias. Because of my warm bias. But yeah, my honest reaction was most likely that. Oh boy. You don't exactly look good. Yeah, it's more like. Yeah, that was my honest reaction when I saw the Sicilians. But then, you know, I remembered my trad wife rating, which was higher than actual women. It was higher than actual women trad wife rating. And I might need to lower that just a bit. You know, just a bit. You know, by going into Sicilians. And I'm going to talk a lot of aspects of the life of Sicilians that you didn't think. That you didn't want to think about. So, back to the wormy boys. Back to the little wormy boys. So, Gymnos and Office. Gymnos and Office for naked serpent, so Gymnophius. And represented by the Sicilians, which in Latin mean the blind ones. Was that a goddamn Rosemi? No, that was me. That was me. I did a meme thing. That was. Don't you recognize me? Don't you recognize me? Oh boy, I'm wounded. I'm wounded by that. But the Sicilians are most likely, like, they're ancient, but they're not so ancient. They appeared about 250 million years ago, if I remember right. So it's about the Triassic. And you need to understand something, is that mammals appeared about the same at about the same time. So it most likely have been, like, you know, somewhat similar to the apparition of mammals. Invasive Rosemi cognition. I see that as you that you have your Canadian wife right to your heart. Thank you. Your Niji wife. And there's more than 220 species of Sicilians that have been recensed right now. With they have teeth, pedicellate teeth, which are very particular types of teeth because they have a lingual cup, they have a labial cups. That's true. They have a crown, and they have a pedicel. And between them, you have a zone of weakness because there's uncalcified dentin. So you know dentin, the actual structure that makes the teeth, which is both protein and minerals. Well, turns out they have a part that is uncalcified here, which means that it has a zone of weakness. And it is specific to amphibians. You just think he's cute? She is cute. She is indeed very cute. I mean, there's no shame in saying it. She's actually super cute. She's actually super cute. Very partition. And that makes them somewhat fragile. Ooh, Elira. Oh yeah, I know. Burb. But yeah, the repetition makes it so that only a few of us could actually see them in the wild. I'm thinking about the Indian bros, and especially Central and Latin America. I mean, somewhat North America, since Mexico is included in that. And there's some of Africa and all that. And it has been thought that they developed, and then when the continent separated, well, that was it. Since you see that there's a lot of them, like most of them are in the Americas. Most of the actual repartition is within the Americas. Although we can find them in Asia and in Africa, in both coasts of Africa. And they're pretty cool. They're pretty cool. They participated into the sex update. I hate Valtrax. I hate Valtrax. I don't like the flying jet wyvern. For one reason, it doesn't make sense ecologically. I mean, dragons don't, but you know what I mean. They especially don't make sense. And there's only one that's allowed to not make sense, in my opinion. It's Fatalis. But yeah, when it comes to Sicilians, they exclusively reproduced using internal insemination. Sicilian males have something called a phallodeum, which is like a tube-like organ, which is inserted in the female's cloaca for a pretty long time, so about 2 hours, and then they insert, and then the fertilization happens. So think of it. Think of it. It's like snake. It's like slime. Snake, slime, teeth. Like taking a long time. Bestiality. But it's like, just imagine the amount of culture that you could create just with this information. Some Sicilians are oviparous and will indeed lay eggs in terrestrial nests, with some species hatching fully metamorphosed and some not. But when they don't hatch, when they hatch as a larva, they quickly go back into being metamorphosis. They quickly do the metamorphosis part. And the majority of Sicilians are viviparous. Like I saw a number about 75% of them being viviparous. Oh, fuck it. Selen is good. I don't no. It's because Selen has feathers. Selen has feathers. And yeah, so the majority, like I saw the number 75% said a lot, but I don't know what amount of misinformation it is. Like I don't know if I can trust that. So I will simply say a majority of Sicilians that we know are viviparous, and the fetus will be fed inside the female. They have a vitellum. As you may have seen, they do have a vitellum. Yes, here. Here, you could see that they do indeed have a vitellum that is caught within the tail. But it's not enough to actually put to term an animal when you don't have a direct line to the mother. Like the vitellum is fine, but then it's not really fine. Like it's fine for the first stages of development, but then not. So the females secrete a layer of cells that line their uterus, and the larva has specialized teeth to scrap them out. So that is actually a motif. Like the fact of eating the mother is actually a motif with Sicilians, because Sicilians actually do parental care. They actually do parental care, which is something that is not present in a lot of amphibians. Like you see a lot of things with amphibians, with a lot of parental investments and absolutely no parental investments at all, depending on the amphibian. In Sicilians, you see a lot of parental investment. A lot. Like, so much so that a species develop a modified outer layer of skin, especially made to feed the young. So instead of lactating, this Sicilian mother, when she's brooding, will actually create a layer of skin which is denser and fatter than the actual layer of skin when she's not brooding, and I will show it to you. And this outer layer will be eaten by the small ones, by the youngs. Of course, having this kind of parental investment will protect the youngs, protect it from dehydration, since it will be inside of a nest that is especially prepared by the parents. And it allows to create fitter young that will carry these benefits into adulthood. So you need to understand that having this kind of alimentation during the first days of life can carry a lot of benefit, like this added protection, lack of stress, and actual how to say, this lack of actual hunger will allow the Sicilian to grow very rapidly, and this benefit will carry on to adulthood. So very fit female will have the best outer layer of skin to feed their young, which will create fitter young. I saw a study too, which was pretty interesting, in which the Sicilian mother by gifting its skin to its young actually seeds its gut flora, actually seeds its intestines with bacteria, which is pretty interesting because this kind of parental care usually comes by eating feces. You see it in rabbits, you see it in birds, you see it in mammals, you see it in marsupials with koalas. This kind of insemination of the gut flora is of seeding of the gut flora for the youngs is usually done through feces or not at all. And here it's done through this gifting of skin. So give me your skin. Give me your skin. But yeah, this also add to the skin microbiota. The skin microbiota, which would help in both yeah. But in both cases, eating the skin and living on the skin of on the mother allow the young to have both their mother's microbiota and skin microbiota, like the gut flora and the skin microbiota, and that allows them. Give me your skin. That allows them to be fitter, but I would say that if the mother is diseased, that presents some risks because it would sacrifice the youngs. But then, if the mother is diseased, it's not going to be a great time for anyone. But I found a study on Nature, but I will not cite because these fuckers have wanted me to pay to actually find the study. Finding this image, I can't find it in better resolution because once again, it's fucking Nature. It's fucking Nature, so if I wanted it in greater resolution, I couldn't. But I'm going to explain the thing to you. So this is a non-brooding female, and they did biopsies of the skin. And here you see the epidermis. This is the derm. So you know, it's perfectly normal. Epidermis, derm, outer layer of the skin. And here they did a fat detection. They use a chemical to detect fat, which you can see here in brooding females. First, you see that the skin is way less dense. It has all those granules inside of it. And you see that those granules are actually full of fat. Yeah, damn perils. I don't want to pay 40 euros to watch a single article that I will not see again. Like that is horrible. I don't like that. And that actually limits the scope of what I can do for the Parasite classes. Like a lot of things are pretty limited in what I can do because I try to read the article before I cite it. I read the article. I read even like the abstract, trying to find the reaction, the response, etc., to know that it has been peer reviewed and it's about for the time that it has been published on, it will actually be good information. I can't do that here, and that pisses me off. Because it's access to information that first I don't have, and then you don't have, and that's information that I cannot include in all honesty to my Parasite classes. Because if I were to put an unverified claim into my Parasite classes, that would suck. That would actually suck. But something that is very, very cool about the skins of Sicilians, once again, and it's that, well, some of them, like a lot of amphibians, evolve poisons, but also venom. Like, you see a lot of poison glands here. They might also develop antibacterial molecules inside of their sweat, inside of the skin glands. Like, Sicilians have a lot of adaptations within their skin. And they need to be studied more because they're not studied that much. But see, here you see the teeth of the Sicilian, and here you see glands near the teeth that will secrete all those enzymes. So of course it produces mucuses, lipids, and proteins, but within these proteins it produces enzymes, gelatinolytics, caseinolytics. Casein is a protein. Voice of a Pirate Legion. I hate paywalls! I hate paywalls! I hate paywalls! I Yeah, pretty much. Fibrinolytic, hyaluronidase, and phospholipase A2. Very important, all those three ones, because this is generally like digestion, is basically digestion for this one. But this one, fibrinogen, is actually a protein that is very important for the tissues, especially the intracellular matrix. So it would destroy a protein that is very important for the integrity of the intercellular matrix. Hyaluronidase, same. Absolutely same. Phospholipase A2 provoke inflammation. So what it does is that it secretes what it does on the teeth. It bites you, and then it injects the venom like that. Like, it's not about injecting the venom, because they don't have cannules. They don't have any tubes, cannules, or any systems to actually have the venom penetrate and inject it into you. They bite you, and the teeth are coated into the venom, which I find really cool. It's like the Gila monster. It's basically the same system as the Gila monster. And you don't need a lot of venom to do a lot of effects. And the scientists that have been doing this study think that this adaptation, which is pretty similar to snake, you know, venomous bite, comes from the fact that they have this worm lifestyle. I mean, they call it a snake lifestyle, I call it a worm lifestyle. They have this worm lifestyle that don't give them a lot of weapons. They don't have claws. They don't have anything to grip except their teeth. So if they want to secure a prey and a bite, having a chemical weapon within your mouth, which contains all of your weapons anyway, is pretty much a pretty good solution. It is a pretty good solution. Of course, you're blind too. They're pretty much blind. So yeah, Sicilians live a pretty hard life. I mean, when you look at the point of view of a monkey and sub-dimensional parasite worm. But yeah, the teeth aren't just there to look pretty. They hunt things that are bigger than them, that are about their size and bigger than them. I wanted to include the one that was hunting a rodent. Was hunting a rodent, but that would maybe be too much for YouTube. Like worm on worm violence is apparently less controversial. So yeah, they are great predators of the dirt world, of the dirt dimension. I'm going to call it the dirt dimension. Of the dirt dimension. They are great predators of the dirt dimension because they eat earthworms and crickets and cockroaches and beetles and crabs. Like they are able to do some durophagy, and you wouldn't believe given those teeth. And I insisted on the fragility of the teeth, on the fact that it has an obvious weak point. The teeth have an obvious weak point, and yet they are still able to do some durophagy, which is insane. And ants. Different species usually have very different diets. This is the study of two species that share about the same ranges, but they apparently do not have the same diet. So there's very few competition when it comes to them, and they have pretty cool teeth. Right, as you can see, like this is a human thumb. They are very, very small. Like Sicilians are very, very small. But this is an earthworm. This is an actual earthworm. So they eat their prey, and they are pretty violent when it comes to their prey. They eat them alive. I mean, of course, this diet is mostly carnivorous. All of them are mostly carnivorous. They have a very rich and very protein-rich diet, and this diet can include young rodents. Unfortunately, there is a decline of the population, most likely due to habitat change, due to climate change, use of agrochemicals, aggressive tilling of the soil sometimes. Agriculture is not actually all bad for them, because in some cases it came to the fact that it didn't affect them at all, and in fact it increased the population of some Sicilians. Like agriculture and irrigation less forest, so more dirt, so less roots, so more dirt that is pretty toiled, and with irrigation that is regularly hydrated. It's actually pretty good. It's actually a pretty good environment for a Sicilian, especially since they don't take to the water that much. I mean, they live near the water, but they don't take to the water. Contrary to other annelids. No, not annelids. Compared to other amphibians. And yeah. Fortunately, that was the end. Unfortunately, that was the end for today. That's a good point. At the end. That is the end for our friend, the little Sicilian. And now the future is pretty bright for them. Like, they're cool. I think they're cool, and I hope that your opinion of them became pretty cool too. I hope that you have a pretty cool opinion of them too after that. I like my little wormy boy, and I really wish, I really do wish that they would be known a bit better. Like seriously, they would be so they would be like, if they have some good conservation, that would be great. 10 years shit eating grid, yeah, absolutely. Like, I would love to see a Sicilian Vtuber. Like, you know, you don't do a snake Vtuber, you don't do a worm Vtuber, because that's me. That's me here. No, you do a Sicilian. Hey, you don't need to be an axolotl. You don't need to be a newt. You don't need to be a frog. You can be a Sicilian. No one takes the Sicilian. Come on, be a Sicilian. They're small and cute. And they give me their skin. But it's fine. I hope that you actually liked this episode. I know that it was a very fast episode, but it was condensed. It was condensed. You don't need to be a Lotte Shinju. What is Lotte Shinju? Who is Lotte Shinju? Lotte Shinju. Oh, Axolotl. Yeah, Axolotl. I mean, there's another. Oh no, she was a Nil. She's a Nil. Yeah. So yeah, it's good. It's cool and good, and yeah. You don't need to be. You can find a lot of actually cool species. If you search like the least researched species, you can find a lot. I mean, you could be a Costa Rica golden frog and have in your lore that you are so sad that every single one, like, you are the last one. You are the last one. And you know, try to do more effort for conservation. Also because the golden color is actually pretty good. Like, a golden coloration hasn't been done. Like, mostly golden. I haven't found someone that is mostly golden and that is big. Yeah, I haven't found someone that is mostly golden and yellow that is really big. I mean, Amy in phase 3, but Amy is still very new. She's still new. That's yeah. Yeah. Next episode will be episode on Pepe. It will be the Pepe episode. I hope that you appreciated it, that you liked it, and that you will see me tomorrow, because tomorrow will be Monster Hunter World, and I'm going to see you. You could also put Zumi Dokumi. Zumo Dokumi. No, Zumi. Oh, cute frog. There was also another frog that is also a cyborg, but I don't exactly remember her. So I will. You know what, Sagittarius? You're going to be one of my sources. Give me as much frog VTubers as you know. Mainly popular ones. I mean, ones that actually do streams. Funny little frog lady. Ah, I'm sure going to discover her. Actually, she looks really cute. She looks kind of cute, yeah. She looks really cute. Ah, she's from Iron. I don't check them out a lot, so I wouldn't have known. I wouldn't have known. I don't check them out a lot. So it was my absolute pleasure, and I will see you tomorrow on Twitch for Monster Hunter World. We're going to punch this his thing. That's it. Bye. I remember now. It's called a Brachydios. I remember now. The thing is Brachydios.